Okay, greetings class, and welcome to another exciting edition of Programming for Engineers. This is the should be the final installment of our File I/O segment, our series of so far 4 videos focused on reading and writing from files. And we're going to wrap this up with a very short video, which is about being able to write to a text file in C. And I want to kind of recap here a little bit and remind you that we've been really focused on primarily these 5 functions that are in the standard I/O library. And we've talked about all of these thus far except for one, which is what I want to show in this video right now. And this is the fprintf function. And this is the function that we're going to use to actually write data to a file. So far, everything we've seen has really been in terms of reading content from a file and reading it into the program's memory. Okay, now we're going to go the other direction. We're going to take something that's in the program's memory and actually write it out to a file. And that's actually an easier process than going the other direction. Okay, so this is pretty straightforward. I want to recap. Okay, just like we've seen in the past, we have to open a file before we can do anything with it. Okay, and I want to remind you of the file mode. The file mode gives us the permissions level to say, okay, we're opening the file under what access level, okay? And if we're going to be writing to a file, we're going to be using, we're going to start with looking at the W mode, right? So R's for reading, W's for writing. We'll also look at append as well, so we can actually continue to append to a file that's already been created, okay? And we'll look at some of the differences between those two, okay? So let's look at an example first. Let's take a look at this example here. And it's a pretty short example, and it's we've got this similar flow that we've seen in the past where we're opening a file, okay, and notice the mode here is W. We're opening it for writing, okay. We're going to have our error checking like we've seen in the past, right? We're going to have our error checking that makes sure that we're able to open the file successfully. You always want to do that, very important. Okay, and also I just want to point at the end here, we got something similar where we're going to be closing the file too. Okay, always want to make sure that we're closing the file when we're done using it. Okay, that's especially important when it comes to writing from files because, as you've seen in the past, right, you don't want 2 programs writing to a file at the same time. What happens when you're opening a file for writing is you're effectively locking that and saying, hey, nothing else can write to this file, right? I'm using it, I'm editing it, right? You're kind of locking that file down saying, hey, I'm using it, and you're preventing other programs from using it. So it's very important that when you no longer need to be writing to it, that you not only do you release resources that you've used for opening the file, but you also make it available for somebody else to use, okay? All right, now the heart of this, the stuff that's really new, is these lines here, 16 and 17, okay, where we're writing to a file. And the good news about this is it's super similar to what we've seen in the past. And that fprintf works really the same way as the printf function that we've been using repeatedly, except we have this one additional input parameter, the first input parameter, which is the file pointer, okay? So this is saying, hey, I want to write this information, but instead of writing it to the console, instead of writing it to the screen, I want to write this out. I want to send this information into a file. Okay, all right. That's the key idea. So let me run this. We'll take a look at it, and then we're going to change it up a little bit. All right, and then we'll wrap up the video, keep it nice and short. Okay. All right. So first, let me go ahead and compile this, and I called it example 4. Okay, I'm going to run it. Okay, and it looks like nothing happened. Right, and that's because, right, what actually happened here is we wrote this to a file, right, called outfile.txt. Right, if I delete that file, outfile.txt, rm is the Linux command for remove. Right, now ls shows me everything that is in this current working directory. Notice outfile's not there. If I run the executable again, right, then do ls, print everything in the current working directory, we see outfile was created. Okay, so this program created that file as it ran, okay, and I can open it, and we'll see here that when I open the file, Okay, we have this hello and 1, 2, 3 was written. Okay, was written to the outfile.txt. Okay, so we wrote to that file here. Now let's change this up a little bit and let's kind of see how if we change up the logic of the program a little bit, what's going to happen. All right. So for one, right, let's see a couple little things. I want to just make it very clear that if I have a variable, say x, okay, I can use printf just like I would print any other information with printf, where I can use a format specifier and I can go ahead and print that value, right? But in this case, instead of printing to the screen, I'm sending that into the file, okay? Right, so I can use the format specifier and say, hey, x, this integer, is going to replace that, just like always, except the key thing is both fprintf and fscanf, they work just like their other, like scanf and printf, except they have this one additional file pointer input parameter. Okay. Let me run this right now, and I want to show something. Right, let's go ahead and I'm going to recompile it because we changed the logic. I'm going to go ahead and run this. Okay, and let's look at the file was updated. Right, it's modified. I'm going to open it, and notice I want to point out something. Right, we got the 5 printed to the screen just as we would expect. However, right, notice that we also deleted the old file. Okay, we deleted the old file, we deleted it and created a new file with that information. Okay, so the stuff that we previously had in there was wiped, and we added this. Now that's not always what you want, right? Sometimes you want to just continue adding information at the end of a file. Okay, and we could do that if I change the mode here from W to A for append, right, to A for append, okay, and then just for the sake of showing a more thorough example, maybe we have a string, and maybe some double, okay, and I want to print these to the file. Well, I'm going to be doing it just like we would have seen in the past, just like those other examples we've seen using printf, right? Where I'm just going to use the proper format specifier, okay, and I'm going to use this just like printf, okay. And notice that now, because I'm using append, what should happen is the old information should stay. Right, we currently have the out file has 5. Okay, currently has 5. Notice I'm not writing 5 anywhere in the file in this logic. Okay, but because I'm using append as the mode that I'm opening the file with, it should just add that information at the end of the file. Okay, let's run this. Let's test this and make sure it's working the way that we're expecting. Okay, I'm going to recompile, and let's see. It looks like I typed something in wrong here. Let's take a look. I forgot a semicolon on line 17, which you probably all saw watching at home. Okay, let's recompile this again. Let's go ahead and run it. Okay, again, looks like it did nothing because it sent all the information to the file. I'm going to open the file here. Okay, and notice it appended that information at the end. Okay, so that is writing to a file in a nutshell, particularly writing to a text file. Text files, right, are things that you can open in, like, say, Notepad and look at, right, and you can actually read it, right? It's human readable. We could do stuff similar writing binary files as well. So, if you're doing things like video, audio, so pictures, things like that, right? That's all binary data, things that you can't just open up in Notepad and look at, okay? And we could also, with just some slight modifications, write binary information as well. But that's for another day, okay? And for now, right, this is kind of wraps up our discussion at being able to read and write from text files, or from or to text files in C. And we'll keep this video short and sweet. Feel free to ask questions. I hope everybody's being safe, healthy, and happy. And feel free to reach out to me at any point to clarify this. And always remember, practice, practice, practice at home, right? You're not going to remember this stuff unless you build things, unless you solve problems, right? Unless you work and struggle through it, right? To be able to do this, to actually build things, right? That's how you really learn. That's how it sticks with you in the long term, okay? Take care, and thanks for watching.